बिस्मिल्लाहिर्रहमानिर्रहीम। ऑनलाइन क्लासेस के सिलसिले में हिदायतुल्लाह खान सब्जेक्ट स्पेशलिस्ट केमिस्ट्री आपसे मुखातिब है। आज का जो हमारा टॉपिक है वो है आइडियल गैस इक्वेशन। पहले आपके लिए जानना जरूरी है कि आइडियल गैस होती क्या है। आइडियल गैस हम उस गैस को कहते हैं द गैस which obeys all the gas laws. Exactly. हर वो गैस जो आइडियल जो तमाम जो गैस लाज हैं उनको एग्जैक्टली ओबे करते हैं, उन तमाम गैसेस को हम आइडियल गैसेस कहते हैं। एक्चुअली ऐसी कोई गैस एग्जिस्ट नहीं करती, दीज आर हाइपोथेटिकल गैस लोग कहते हैं। तो हमारे पास आइडियल गैस के कुछ लॉज हैं। एक बॉयल्स लॉ है जो रिलेशनशिप एक्सप्लेन करता है बिटवीन द वॉल्यूम एंड द प्रेशर ऑफ द गैस। यहाँ से पी से मुराद वॉल्यूम, पी से प्रेशर, टी से टेम्परेचर और एन से नंबर ऑफ मोल ऑफ गैस। According to the Boyle's law, if we keep the number of mole and temperature constant, the volume of the given mass of a gas is inversely related to pressure. Means inverse relation means if the one value increases, the other will decrease. So according to Boyle's law, increase in pressure will bring the decrease in the volume of the gas and vice versa. Similarly, according to Charles' law, the volume of the given mass of a gas is directly proportional to temperature. Means with increase in temperature, the volume of the gas will increase. According to Avogadro's law, the volume of the given mass of a gas is directly proportional to the number of mole of a gas. Means the number of mole, if it increases, then the volume will also increase. Now, actually, the ideal gas equation is the combination of all these three laws. Therefore, this gas equation, ideal gas equation, is also named as combined gas equation. इसको combined gas equation भी कहा जाता है क्योंकि इसमें एक्चुअली हम तीनों laws को combine करते हैं. So, if we combine the above three laws, we get V proportional to 1 over P, T and N. Mean V proportional to NT divided by P. When we change the sign of proportionality to the sign of equality, we introduce a constant. Here we introduce a constant R, which is known as universal gas constant. इसको हम आइडियल गैस कांस्टेंट भी कहते हैं. Now on real engine, P multiplied by V is equal to nRT, or R is equal to PV when we bring in NT here when it is divided by PV. So R is equal to PV by NT. Now if we have two different conditions, means if these conditions are changing with the time, then P1 V1 divided by N1 P1 is equal to P2 V2 divided by N2 N2, because from these equations we will get the constant value. So this equation can be used for mathematical problems. As we have discussed earlier, that this is the combined gas equation. Because in this gas equation, all the three laws, Boyle's law, Charles' law, Avogadro's law, have been combined. So we can derive all these laws from this equation. How? Let's see. Now if we take V volume and number of mole constant, then what we will get? V1 is equal to V2, because T and N are constant, means they are not changing. So this is Boyle's law. Similarly, if we take P and T both constant, then what we get is V1 by N1 is equal to V2 by N2. P and T are constant. This is the value. Therefore, this law is also known as combined case law, combined case equation, or ideal case equation, because this is actually the combination of three ideal case laws: Boyle's law, Chargas law, and Avogadro's law. Now, we will discuss the application of ideal case equation. इनके लिए इस हम और क्या क्या चीजें कैलकुलेट कर सकते हैं इस आइडियल केस इक्वेशन से? सबसे पहले यहाँ पे पहले से मैंने लिख दिया है, थोड़ा टाइम की बचत के लिए। हम इसकी मदद से किसी भी गैस का मास कैलकुलेट कर सकते हैं। कैसे? हमारे पास ये इक्वेशन है आइडियल गैस इक्वेशन, PV इज इक्वल टू nRT। P pressure of the gas, V volume of the gas, N number of mole of the gas, T temperature of the gas, and R is the universal gas constant or ideal gas constant. Now we know that number of mole is equal to mass in grams divided by molar mass. Mass in gram is represented by small n, while molar mass is represented by capital M. So put the value of n is equal to m by n here in this equation. So we get PV is equal to m by m or P, because n is equal to mass in gram divided by molar mass. Now on real element, PVm is equal to mRT, or m is equal to PVm divided by RT. So from this equation we can calculate the mass of gas. This is the application of ideal gas equation. If we know the value of pressure, volume, and molar mass and temperature of the gas, then with the help of this equation, ideal gas equation, we can calculate the mass of the gas. Now the second application of the ideal gas equation is that we can calculate the density of the gas with the help of this ideal gas equation. How? Let's see. We know that P is equal to nRT. This is the ideal gas equation. Similarly, as in this case, we put the value of n is equal to small m divided by capital M here in this equation. Put the value of n is equal to small m by capital M, RT. Now on rearrangement, if we put this V here, then it will be divided by m. So m by V or T, and P multiplied by m. Now we know that mass per unit volume is called as density. So m by V is equal to D, density. So we put D instead of m by V. So Pm is equal to dRT, Pm is equal to dRT, and on rearrangement we get D is equal to Pm divided by RT. So if we know the value of pressure, molar mass of the gas, temperature of the gas, then with the help of ideal gas equation we can calculate the density of any gas. So these are the two main application of universal gas ideal gas law. Similarly, we can calculate the concentration of the gas. How? We know that PV is equal to nRT. On rearrangement, P is equal to N by V RT. Now we know that this is equal to concentration. Number of mole of gas in unit volume. So P is equal to CRT because C N by V is equal to C. Now on rearrangement, C is equal to P by RT. So if we know the value of pressure of the gas, temperature of the gas, and R, by putting these three values in this equation, we can calculate the concentration of any gas. So these are the application of the ideal gas equation. Now, what is R? What is the value of R? Yes. Calculation of value of R in different units. The value of R जब हम कैलकुलेट करते हैं, आप ये कह सकते हैं कि this is also the application of ideal gas equation because we calculate the value of R from the ideal gas equation. We know that PV is equal to nRT. R is equal to PV by nT. So if we put the value of PV and nT, then we can calculate the value of R. Now, first of all, if we take standard temperature equation, means we want to calculate the value of R at STP. So we know that जो standard temperature होता है वो होता है 273 Kelvin. Standard pressure जो है वो होता है 1 atm, one atmospheric pressure. N is equal to 1 mole, and we know that at STP the volume of 1 mole of any gas is 22.4 dm cube or liter, because dm cube is equal to liter, cubic decimeter. So if we put all these values here in this equation, we can calculate the value of R at STP. Let's try. R is equal to P 1 atm, V 22.4 liter or ml cube, cubic decimeter. Number of mole is equal to 1 and 273. From this multiplication and division, we get the value of R as 0.0821 per mole per Kelvin. Here you can put a liter as well, 0.0821 liter atmospheric pressure per mole per Kelvin. So this is the value of R. Now we can calculate the value of R in some other units as well. Like if R is equal to N PV, sorry, PV by N. If R is equal to 22.4, सॉरी पहले हम P की वैल्यू पुट करते हैं. We know that 1 atm atmospheric pressure is equal to 760 mm of Hg. So 760 mm of Hg, 22.4 liter. Number of mole 1 and 2, 73 Kelvin. Then we will get, by multiplying and dividing all these values, we get 62.396, almost 62.4 mm Hg into liter mole per Kelvin. So this is the value of R in different unit terms. Similarly, we can calculate the value of R in SI units. Now 1 atm atmospheric pressure is equal to 11325 Newton per meter square, or 101,325 Pascal. Similarly, the unit of length, SI unit of length is meter. Now, if we take volume in cubic meter, then what we get? R is equal to P 101,325 Newton meter per meter square. Newton into meter is equal to joule. If you apply 1 Newton force on a substance and it covers the distance of 1 meter, it means work or energy is equal to joule. So we put joule here instead of Newton into meter. Now similarly, you can calculate in the value of R in units is 1 calorie is equal to 4.184 joules. So 8.3143 divided by 4.184 calorie per mole per calorie. So this is R most equal to 2 calorie per mole per calorie. So these are the values of R in different units. We can calculate the value of R at standard temperature and pressure. We know that standard temperature is equal to 0 degree centigrade or 273 Kelvin, while the value of standard pressure that is equal to 1 atmospheric pressure. So we can just interconvert the different units and can calculate the value of R in different units